if a to the power n plus b to the power n by a to the power n minus 1 plus b to the power n minus 1 is the arithmetic mean, geometric mean and harmonic mean between any two numbers a and b. A power n plus b power n by a to the power n minus 1 plus b to the power n minus 1 is the arithmetic mean and geometric mean and harmonic mean between a and b for n is equals to 1, 1 by 2 and 0 respectively. This quantity is nothing but a to the power n plus b to the power n by a to the power n minus 1 plus b to the power n minus 1 represent arithmetic mean. Already we discussed in the previous class. If the value of n is 1, it is represent geometric mean is nothing but n is equals to 1 by 2. It represents a harmonic mean when n is equals to 1 0. Clearly, easily we have to substitute n is equals to 1 by 2 0, we get the answer. For example, if n is equals to 1, the value is a to the power n plus b to the power 1 by a to the power 1 minus 1 plus b to the power 1 minus 1. A to the power 1 is nothing but a only, b to the power 1 is nothing but b only by a to the power 0 plus b to the power 0. A plus b by a to the power 1 value 1, a to the power 0 value 1 plus b to the power 1 0 value also 1. That is equals to a plus b by 2 is nothing but arithmetic mean between any two given numbers. So n is equals to 1. This quantity represent arithmetic mean between a and b. Arithmetic mean between a and b. If n is equals to 1 by 2, if n is equals to 1 by 2, if n is equals to 1 by 2, substitute here a to the power 1 by 2 plus b to the power 1 by 2 by a to the power 1 by 2 minus 1 plus b to the power 1 by 2 minus 1. We get here a to the power 1 by 2 plus b to the power 1 by 2 by a to the power 1 by 2 minus 1 is nothing but a to the power minus 1 by 2 plus b to the power 1 by 2 minus 1 is nothing but b to the power minus 1. That is equals to a to the power 1 by 2 plus b to the power 1 by 2 by. We know that a to the power minus n is equals to 1 by a to the power n. So this can be written as 1 by a to the power plus 1 by 2 plus 1 by b to the power plus 1 by 2. That is equals to a to the power 1 by 2 plus b to the power 1 by 2 by. Here LCM is a to the power 1 by 2 into b to the power 1 by 2 is LCM. So a to the power 1 by 2, a to the power 1 by 2 is get cancelled. We get here b to the power 1 by 2 plus b to the power 1 by 2, b to the power 1 by 2 get cancelled. We get here a to the power 1 by 2. So this can be written as a to the power 1 by 2 plus b to the power 1 by 2 into it's reciprocal, is nothing but a whole to the power 1 by 2 by a to the power 1 by 2 plus b to the power 1. Here a to the power 1 by 2 plus b to the power 1 by 2 by a to the power 1 by 2 plus b to the power 1 by 2 get cancelled. This is exponential form, can be converted into radical form. This is square root of a is nothing but geometric mean between a. If substitute n is equals to 0, if substitute n is equals to 0, we get a power 0 plus b to the power 0 by a to the power 0 minus 1 plus b to the power 0 minus 1. A to the power 0 by how much? 1 plus again 1 by a to the power minus 1 plus b to the power minus 1. That is equal to 1 by 1 is nothing but 2. A to the power minus 1 can be written as a 1 by a plus this is 1 by a. If you do LCM 2 by a b is LCM a 1 by a to b 1 by is nothing but a plus c. If you write it in reciprocal we get 2ab by a plus b is nothing but harmonic mean between any two given numbers a and b. So a to the power n plus b to the power n by A to the power n minus 1 plus B to the power n minus 1 represent arithmetic mean when n is equals to 1. It represents geometric mean when n is equals to 1 by 2. It represents harmonic mean when n is equals to 0. This is the fifth property. Yes. Next one. To find nth term by difference method. To find nth term by difference method. We know that sum of first n natural numbers. Sum of first n natural numbers. Sigma n is equals to what? Sum of first n natural numbers. Sigma n is equals to n into n plus 1 by 2. Already we know the sum of first n natural number. 1 plus 2 plus 3 plus 4 plus up to n. We get sigma n is nothing but n into n plus 1 by 2. Sum of the squares of the first n natural numbers is nothing but sigma n square is equals to, already we discussed in previous class. Sigma n square is equals to is nothing but n into n plus 1 into 2n plus 1 by 6. This is sigma n square. And sum of is nothing but 1 square plus 2 square plus 3 square plus 4 square plus up to n square. We get n into n plus 1 into 2n plus 1 by 6. Sum of the cubes of first n natural numbers. That means 1 cube plus 2 cube plus 3 cube plus 4 cube plus up to n cube. We get n square into n plus 1 whole square. This is the formulas. Sigma n is equals to, sigma n is nothing but sum of the first n terms. Sum of the first n terms is equals to n into n plus 1 by 2. The sum of the squares of the first n terms. The sum of the squares is nothing but 1 square plus 2 square plus 3 square plus 4 square up to n square. We get n into n plus 1 into 2n plus 1 by 6. The sum of the cubes of first n natural numbers is nothing but 1 cube plus 2 cube plus 3 cube plus n so on plus n cube. We get n square into n plus 1 by 4. Sometimes they don't know given sequence is arithmetic progression or geometric progression or harmonic progression. Not at all in arithmetic progression, geometric progression or harmonic progression. Some series. How to find the nth term or Sn means by using of the difference method. By using of the difference method. That means let T1, T2, T3, T4 and so on, Tn are the terms of given sequence or series. Let T1, T2, T3 and so on up to Tn are the terms of the given series. Clearly, these terms T1, T2, T3, T4 up to Tn not at all in arithmetic progression, not a ZP, not a HB, not at all in ZP. How to find the nth term? How to find the nth term means by using of the difference method is nothing but if you let T1, T2, T3 and so on, Tn are the terms of the given series. The difference between any two consecutive terms, the difference between any two consecutive terms is nothing but T2 minus T1, T3 minus T2, T4 minus T3, and so on, Tn minus Tn minus. The difference between the consecutive terms, is nothing but T2 minus T3, T3 minus T2. T4 minus T3 up to Tn minus this before term is Tn minus 1. Tn minus Tn minus 1 are the difference between the consecutive terms are either in AB, that means this difference are in AB or either AB or ZB, either AP or ZB, then nth term or Tn, nth term or Sn may be found by using of difference method. By using of difference method. T1 clearly T1, T2, T3 up to Tn are the terms of the any series, are the terms of the any series or terms of the any sequence. Clearly not at all in arithmetic progression or geometric progression or any progression, but that is clearly one sequence, that is series. We don't know how to find the nth term or sum of n terms, means by using a difference method. What is nothing but, first of all we find the difference between any two consecutive terms, nothing but T2 minus T1, T3 minus T2, T4 minus T3, T5 minus T4, up to so on Tn minus 1. These sequence, if you, the difference between the consecutive terms of the sequence or series, also get the another sequence or series. If this series or sequence, it is in terms are in AP or either in AP or in GP. Either in AP or in GP. Nth term or sum of n terms, nothing but Sn, may be found by using of the difference method. So how to find the nth term Tn means, first of all, Sn means sum of their terms, nothing but T1 plus T2 plus T3 plus and so on up to Tn. This is equation number 1. Second equation, write again Sn is equals to again T1 plus T2 plus T3 plus and so on plus Tn minus 1 plus Tn. This is equation number 2. The before term of Tn is nothing but Tn minus 1. If you do here 1 minus 2, we get here Sn minus Sn is equals to, that is T1 plus this is Sn minus Sn, T2 minus this one, T1 minus T2 plus T2 minus T2 plus T3 minus T2. This can be written as our convenience. Is nothing but T2 minus T1 plus T3 minus T2 plus T4 minus T3 plus and so on plus Tn minus 1 is nothing but this is minus. If you do a subtraction, Sn minus equation number 1 minus 2, 1 minus 2, this signs will be changed in nothing but minus T1, minus T2, minus T3, minus T4, minus Tn minus 1 up to minus Tn. We want Sn minus Sn, S1 minus 2, Sn minus Sn. T1 plus T2 minus T1 plus T3 minus T2 plus T4 minus T3 and so on plus Tn minus 1, we get minus 2. We know that Sn minus Sn is nothing but 0. Is nothing but 0. If you transpose minus Tn here, we get Tn is equals to T1 plus T2 minus T1, T3 minus T2, T4 minus T3 up to Tn minus 1. Are in AP or the difference, the successive terms of the difference, maybe either AP or GP. So it can be written as small as T1 plus T2 plus T3 plus and so on plus Tn minus 1. These T1, T2, T3, T4 and so on are T1, T2, T3, and so on. Tn minus 1 are terms of new series. So Tn, how to find the Tn? Nth term means by using of the difference method. Sn minus Sn, we get T1 plus T2 plus T3 plus these small T1, T2, T3 and so on up to Tn minus 1 are terms of the new series or new sequence. Then we find easily Sn minus Sn is nothing but 0. Minus T1, if you transpose here, we get plus T1. This one we get. This is the difference method to find the nth term. Another method is there that is very very easy. Let us use difference method only. Another one is very very easiest method. If the difference between the successive terms, T2 minus T1, T3 minus T4 minus T3, T3 minus T2, T4 minus T3, and T5 minus T4 and so on, Tn minus 1. If you compute this one, we get these terms are, for example, if these terms are in AB, these terms are in AB. Let Tn is maybe an square plus bn plus c. Let Tn is equal to an square plus bn plus c. An square plus, let us assume that nth term may be an square plus bn plus c. An square plus bn plus c. Let us assume that. Why use bn plus c? Linear equation means the nth term it is in the arithmetic progression. This is not at all an arithmetic progression. So that's why nth term may be Tn is equal to an square plus bn plus c. Tn is equal to an square plus bn plus c. Sometimes Tn is equal to, in arithmetic progression, Tn is equal to an cube plus bn square plus c. N cube plus bn square plus cn plus d. Sometimes Tn is equal to this one or this one, an square plus bn plus c. Mainly we use this one. Tn is equal to an square plus bn plus c. And A, B, C are constant. To find the ABC values, putting the n is equal to 1, 2, 3. That means first term, second term, and third term, and which is equal to T1, T2, T3. Which is equal to T1, T2, T3. We get ABC value. Clearly, we get nth term. The difference between the successive terms are in arithmetic progression. Nth term, let us assume that nth term may be an square plus bn plus c. ABC are clearly it is a constant. How to find the ABC value means putting the values of n is equals 1, 2, 3. If you substitute n is equals 1, we get T1. T1 is nothing but this one. Equal this one, we get ABC values and solve that ABC. We get ABC value. Substitute here, we get Tn. Or otherwise, the successive difference T2 minus T1, T3 minus T2, T4 minus T3, and so on, Tn minus 1, or in GP, or in geometric progression, or in AB, nth term may be an square plus bn plus c, or in AB, nth term may be, let us assume that nth term may be an square plus bn plus c. So this is quadratic equation, not at all take linear equation. If there is nth term is a linear equation, clearly given sequence is in arithmetic progression. So not at all take linear equation. If you take quadratic or cubic equation, solve them, we get the answer. So that's why Tn is equal to an square plus bn plus c. Next, it is in GP. The successive difference of the given series is nothing but this is in GP. So let us assume that Tn is equal to AR to the power n minus 1 plus bn plus c. Let us assume that Tn is equal to the successive difference of the given sequence or given series. It is in GP. Nth term may be AR power n minus 1 plus bn plus c, or AR power n minus 1 plus bn square plus cn plus d. If you take these both, that is the successive difference method. Let us discuss one small example. We will understand this concept. Observe here one example. Find the nth term of the sequence. Clearly, 5, 15, 29, 47, 69, 95, and so on. Observe here, 15 minus 5, how much? 10. 29 minus 15, 14. 47 minus 29, how much? 47 minus 49. 18. Not at all in arithmetic progression. Not a arithmetic progression, and also not A.M G.M. But we want nth term. Not an arithmetic progression, not at all in geometric progression, but we want nth term. How to find means solution here. Observe one time this sequence 5, 15, 29, 47, 69, 95. Given sequence not at all in arithmetic progression and not at all in geometric progression, but we want nth term. But we want nth term. How to find the nth term is by using of the successive difference of its terms. Successive difference of it by using of the difference method. We want successive difference T2 minus T1. In other words, T2 minus T1. This is T3 minus T2 and T4 minus T3 and so on. Clearly, this is T1, T2, T3, T4, T5, T6. T2 minus T1 is nothing but 15 minus 5. Next, T2 minus T1. Next, T3 minus T2 is nothing but 29 minus 15. Next, T4 minus T3, 47 minus 29. Next, T5 minus T4, 69 minus 47. And this is 1, 2, 3, 4, 5, 6. T6 minus T5. And so on. We want the successive difference between the given sequence terms. So 15 minus 5 we get here 10 only. 29 minus 15 clearly it is 14. 47 minus 29. 47 minus 29. 47 minus 29. This is 17. 17 minus 9 is nothing but 8. 17 minus 9 how much? 8. This is 3. 3 minus 2 is nothing but 18. So we get 18. 16. 9 minus 47. 9 minus 7 2. 6 minus 4 22. We get 20. Next, 95 minus 69. 95 minus 69. We get 26. We get 26. And so on. Observe here. This new sequence 10, 14, 18, 22 and 26. The difference between the given sequence, constant terms, the difference between its constant terms, we get 10, 14, 18, 22, 26 and so on. 14 minus 10, 14 minus 10 how much? 4. 18 minus 14, we get 4. 22 minus 18, again we get 4. 26 minus 22, again we get 4 and so on. Clearly the difference it is in arithmetic progression. Clearly the difference between any two constant terms, it forms a arithmetic progression. Given sequence not at all arithmetic progression, but by using of the difference method we want the nth term. So nth term maybe let us assume that in arithmetic progression let us assume that Tn may be nth term of the given sequence Tn may be A.M square plus B.M plus Tn is equals to A.M square plus B.M plus C is the nth term of the given sequence. Nth term of the given sequence we don't know. Not at all in linear expression. Why means in linear expression means given sequence compulsory in arithmetic progression. So that's why that takes quadratic equation or cubic equation or any other equations. So that's why I calculate Tn is equals to will take A.M square plus B.M plus C. Let us assume that the given sequence of nth term may be A.M square plus B.M plus C. How to find the ABC values? ABC are the constants. How to find the ABC values? By putting 1, 2, 3 and so on, we get the terms. So, if n is equals to 1, n is equals to 1, this is T1 is equals to A into 1 square plus B into 1 plus C. T1 is how much? Term 1, 5. 5 is equals to A plus B plus C. Is nothing but A plus B plus C is equals to 5. This is equation number 1. This is equation number 1. Substitute n is equals to 2. N is equals to 2. T2 is equals to A into 2 square plus B into 2 plus C. B into 2 plus C. T2 is nothing but 15. 15 is equals to 4A plus 2B plus C. This can be written as 4A plus 2B plus C is equals to 15. This is equation number 2. Putting n is equals to 3. N is equals to 3. T3 is equals to A into 3 square plus B into 3 plus C. T3 is nothing but 29. 29 is equals to 9A plus 3B plus C. Nothing but 9A plus 3B plus C is equals to 29. This is equation number 3. Solve these 3 equations, we get A, B, C values. We get A, B, C values. If you take A and Q plus B and square plus C and plus D, take 4 equations and solve them, we get A, B, C, D values. So that's why A plus B plus C is equals to 1. So you take second equation, it is 4A plus 2B plus C is equals to 15. 4A can be written as automatically as 3A plus A, 2B, B plus B. So this can be written as 3A plus B plus A plus B plus C is equals to 15. 3A plus A, 4A only, B plus B, 2B, again C is equals to how much? Clearly, A plus B plus C are how much? 5. Substitute here, 3A plus B plus 5 is equals to 15. 3A plus B is equals to 10. This is equation number 4. This is equation number 4. Again, take equation number 3. 9A plus 3B plus C is equals to 29. 9A plus 3B plus C is equals to 29. This can be written as, that is, we take 3 into, this is 3A plus B plus C is equals to 29. 9A, 3 is a 9A, 3 into B is nothing but 3 plus C is equals to how much? 29. 3A plus B value how much? 10. Substitute here. 3 10s are 30 plus C is equals to 29. C is equals to 29 minus 30. C is equals to how much? Minus 1. C is equals to how much? Minus 1. We get A and B values. A and B values. Substitute C is equals to minus 1 in equation number 1. A plus B minus C minus 1 is equals to 5. A plus B is equals to 6. This is equation number 5. If you transfer this one, we get A plus B is equals to 6. This is 3A plus B is equals to 10. By solving 4 and 5, 4 minus 5, here, fourth one is 3A plus B is equals to 10. Fifth one is A plus B is equals to 6. Minus, B we get cancelled. 3A minus A is nothing but 2A is equals to 10 minus 6 is nothing but 4. A is equals to how much? 2. A is equals to 2. A value substitute in equation number 1 or, that is 5 or 4 or 5, we get 3 into 2 plus B is equals to 10. B is equals to 10 minus 6. B is equals to 4. A value 2, B value 4, C value how much? Minus 1. Substitute here, Tn is equals to 4A n square. A means here we get A value 2n square plus Bn. B value how much? 4n plus C. C we get minus 1. This is the nth term of the given sequence. This is the nth term of the given sequence. Observe here, We want 5 is T1. Substitute here T1. 2 ones are 2. 4 ones are 4. 2 plus 4, 6. 6 minus 1. We get 5. We want second term. Substitute 2. 2 square is 4. 4 2s are 8. Again 4 2s are 8. 8 plus 8, 16. 16 minus 1 how much? 15. Take m is equal to 3. 3 square, 9. 9 2s are 18. 18 plus 4 3s are 12. That is 30. 30 minus 1 how much? 29. This is the difference method to calculate. We don't know the given sequence of series not at all in AP and GP. By using of this difference method, we have to find the nth terms. The nth term or Sn, sum of n terms. By using successive difference of the its terms. Okay, this is level 1 conceptual questions. This is first one. Capital A denotes single arithmetic mean between A and B. Capital A denotes single arithmetic mean between A and B. Capital S denotes sum of n arithmetic means. Sum of n arithmetic means between A and B. Sum of n arithmetic means between A and B. Then the value of S by A is equal to. We want S by A. Already we discussed in previous class. A means single arithmetic mean between any two given numbers in nothing but A and B. So arithmetic mean A is equal to what? A plus B by 2. So A is equal to A plus B by 2. The sum of n arithmetic means. The sum of n arithmetic means already we discussed in previous class. Sum of n arithmetic means, that means capital A1 plus A2 plus A3 plus and so on up to AN. We get how much? n by 2 into A plus B. Single arithmetic mean is nothing but A plus B by 2. Single arithmetic mean is nothing but A plus B by 2. Sum of n arithmetic means. Sum of n arithmetic means is nothing but A, capital A1 plus capital A2 plus capital A3 plus and so on up to capital A1, AN. Is nothing but n by 2 into A plus B. So, n by 2 into A plus B. We want S by A. S by, that means n into A plus B by 2 by, again A plus B by 2. S by A is equal to n into A plus B by 2 into, its reciprocal is 2 by A plus B. 2 by A plus B. A plus B get cancelled, 2 get cancelled, we get how much? N only. We get how much? N. Next, NAMs are inserted between n arithmetic means. N arithmetic means inserted between two set of numbers. Nothing but A comma 2B and 2A comma B. Solution. N arithmetic means let NAMs is equal to A1 comma A2 comma A3 and so on AN. Let n arithmetic means nothing but A1, A2, A3 and so on AN are inserted between two set of given numbers. Then first set is nothing but A comma A1 comma A2 comma and so on AN comma 2B. This is the first set. And second set is nothing but this is 2A comma A1 comma A2 comma and so on AN comma B is the second set. Already we know that if NAMs, n arithmetic means are inserted between any two given quantities, then common difference D is equal to. If n arithmetic means are inserted between A and B, then common difference D is equal to B minus A by n plus 1. Here B value 2B, so we get 2B minus A by n plus 1. Here common difference D is equal to, here B value B1, A value 2A by n plus 1. This is the common difference. If n arithmetic means are inserted between any two quantities, then common difference D is equal to B minus A by n plus 1. Here B value 2B minus A by n plus 1. Here a value 2a, so that is b minus 2a by n plus 1. And also further, the nth mean of these sets, nth mean of these sets are same, nth mean of these sets are same, then the ratio of a is to b. Nth means are equal. The nth means are equal. How to find a1? A1 is already discussed in previous classes. A1 is nothing but a plus b. A plus b means a plus b minus a by n plus 1. A2 is nothing but A2 is nothing but A plus 2 times of B minus A by n plus 1. 2 times of B minus A by n plus 1. AN, nth mean is nothing but B minus A by n times of B minus A by n plus 1 nth mean. But we here nth mean of these two sets. Nth mean of these two sets is nothing but AM is equals to A plus A plus m into a plus m into b minus a by n plus 1. b minus a means here 2b minus a by n plus 1. This is the nth mean of the given first sequence. Next, here also am is equals to how much? A plus a is what? 2a plus m times of 2a plus n times of b minus 2a by n plus 1. Given that the nth means are equal, that means this one are equal. So a plus m into 2b minus a by n plus 1 is equal to 2a plus m into b minus 2a by n plus 1. 2a plus b minus 2a by n plus 1. Their nth means are equal. If you transpose a here and this one here, if you take m as common, so we get here 2b minus a by n plus 1 plus denominator same, so total we get here n plus 1 is the LCM 2b minus a. If you transpose this one, we get minus, so minus b plus 2a is equal to 2a minus 2b minus b, we get here m times of 2b minus b, 2a minus a plus a by n plus 1 is equal to b. N plus 1 is equal to how much? If you transpose this one, we want a and b values. This can be written as m by n plus 1 is equals to, if you transpose b plus a from LHS to RHS, it becomes divisible quantity. So a by a plus b. So m by n plus 1 is equals to m by n plus 1 is the full transform this one, it is divisible quantity, that is a by a plus b. Converted to inverted, we get here n plus 1 by m is equals to a plus b by b. Since inverted, reciprocal one, n plus 1 by m is equals to a plus b by b. If you separate the denominator, we get here n plus 1 by m is equals to a by a plus b by b. A by a plus a by a like how much? 1. So b by a is equals to a by a means how much? 1 transpose here from RHS to LHS, n plus 1 by m minus plus 1 can be converted to minus 1. This is b by a is equals to n plus 1, if you do LCM, minus m by m. We want ratio a is to b. So a is to b is equal to, a value how much? m is 2. B value n minus m plus 1. n minus m plus 1 is the m is 2. n minus m plus So, if AMs are inserted between any two quantities, how to find the common difference? D is equals to B minus A by N plus 1. Here B value 2B, so that's why 2B minus A by N plus 1. Here B value D was A value 2B, that's why B minus 2A by N plus 1. How to find the nth term? Nth mean. Nth mean AN is equals to A plus N into B minus A by N plus 1. So, here B minus common difference is 2B minus A by N plus 1. Here also B minus 2A by N plus 1. Then the nth means are equal. If you equate means we get their ratio. Next, let us run third problem. If A1, A2 be two arithmetic means between given two numbers A and B, and G1, G2 be two GMs between A and B, then A1 plus A2 by G1 into G2. We want this solution. A1, A2 be two arithmetic means between two given numbers A and B. That means A comma A1 comma A2 comma B are in AB. A1, A2 are the two arithmetic means between the two given numbers A and B. So A1, A2, B is equals to A. That means A1 minus A is equals to A1 minus A is equals to A2 minus B. A2 minus B. A1 minus A is equals to or A2 minus A1. We want A1 plus A2. A1 plus A2. B minus A. So this is B minus A2. That means the common difference between any two consecutive terms is same. That means A1 minus A is equals to A2 minus A1 is equals to B minus A2. Common difference is always same. So that's why A1 minus A is equals to B minus A. If you transpose here, we get A1 plus A2 is equals to A plus B. A1 plus A2 value how much? A plus B. A1 plus A2 value. Also, G1, G2 is the two GMs between A and B. That means A comma G1 comma G2 comma B are in geometric progression. In a geometric progression, the ratio of any two consecutive terms, is always same. It is nothing but common ratio. Here G1 by A is equals to here B by G2. That means A2 by A1 is equals to A4 by A3. If you do cross multiplication here, G1 into G2 is equals to A into. We want A1 plus A2 by G1 into G2. A1 plus A2 value how much? A plus B by G1 into G2 value A into. This is the answer. A plus B by A. Next, fourth question. A is the arithmetic mean and G is the geometric mean between any two given numbers. What is the relation between A and G means? Already we discussed the properties of relation between arithmetic mean and geometric mean and harmonic mean. Nothing but A is greater than or equals to. Arithmetic mean is always greater than or equals to geometric mean. Next, fifth one. If x is greater than 0, then the value of x plus 1 by x is always greater than or equals to how much? If x is greater than 0, if you take x is greater than 0, 1, 2, 3, 4, and so on, what is the value of x plus 1 by x is greater than or equals to how much? Already we know that arithmetic mean is greater than or equals to geometric mean. Arithmetic mean is greater than or equals to geometric mean. Let us say A is equals to x and B is equals to 1 by x. A is equals to x and B is equals to 1 by x. Arithmetic mean is nothing but arithmetic mean between two given numbers is nothing but A plus B by 2. A plus B by 2. Here A value x plus B value 1 by x by 2 is greater than or equals to. The geometric mean between any two given numbers A and B is nothing but square root of AB is nothing but AB whole to the power 1 by 2. So square root of AB. Here A value x into B value 1 by x whole to the power 1 by 2. Square root of AB is nothing but AB whole to the power 1 by 2. Square root of AB is the radical form If you convert it into exponential form, we get AB whole to the power 1 by 2. So x into 1 by x whole to the power 1 by 2. X and x get cancelled. So x plus 1 by x by 2 is greater than or equal to 1 power 1 by 2. 1 power anything is equal to, we know that 1 only. So x plus 1 by x is greater than or equal to, if you transpose here we get x plus 1 by x is always greater than or equal to. If you take x is equal to 1, x is here, x is greater than 0. X is greater than 0. Take x value minimum 1. Substitute here x plus 1 by x. 1 plus 1 by 1 is nothing but 2. So greater than or equals to 2. If you take 1 by 2, 2 plus 1 by 2, 2 plus 1 by 2 is nothing but 5 by 2. That is 2.5. So always greater than or equals to 2. So x plus 1 by x is always greater than or equals to 2. Next is problem. What is the value if theta is lying between 0 and pi by 2? Theta is lying between 0 and pi by 2. What is the value of tan theta plus cot theta? Tan theta plus cot theta is always, observe here, if you take theta value, if you take theta is 45 or 30 or 60, we want theta is always lies between 0 is less than, theta is less than pi by 2. So if you take, for example, theta is equal to 45, tan 45 plus cot 45. Tan 45 value 1 plus cot 45 value 1. So this is 2. So tan theta plus cot theta is always greater than or equals to, always greater than or equals to. Or otherwise, we use this one. Arithmetic mean is greater than or equals to geometric mean. Tan theta plus cot theta by 2 is greater than or equals to tan theta into cot theta whole to the power 1 by 2. We get same answer. So answer is greater than 2 or greater than 2. Tan 45 plus cot 45 2. So this value tan theta plus cot theta is greater than, always greater than or equals to 2. Next problem. Arithmetic mean is 8 and geometric mean is, harmonic mean is 32. Then we want geometric mean. Arithmetic mean of two given numbers is 8 and harmonic mean of two given numbers is 32. We want geometric mean. Already we know that the geometric mean is equal to geometric mean square is equal to arithmetic mean into harmonic mean. Nothing but g square is equal to a into h. G square is equal to ah. That means geometric mean whole square is equal to arithmetic mean into harmonic mean. Geometric mean whole square is equal to arithmetic mean into harmonic mean. We want geometric mean. So GM whole square, geometric mean whole square is equal to arithmetic mean here 8 into harmonic mean here 32. 8 into 32. So GM is equal to square root of 8 into 32. 8 to 16. 8 3 is 24. We get 25. So 256 plus or minus 256. So geometric mean is equal to how much? Plus or minus 16. 16 256. 16 into 16. 6 6 36. 6 1 is 6. 9. 1 6. 1 1 6. 15. 256. So geometric mean is equal to how much? 16. Next problem. The ratio of harmonic mean and geometric mean is 6 is to 10. The ratio of harmonic mean and geometric mean is 6 is to 10. Then the ratio of the numbers is. Already we know that harmonic mean is nothing but 2ab by a plus c by geometric mean of two numbers is nothing but square root of ab is equal to 6 is to 10. Is nothing but 6 by 10. So this can be written as 2ab by a plus b into, this is 1 by square root of ab is equal to 6 by 10. AB can be written as 2 times of square root of AB whole square. Square root get cancelled, we get AB only by A plus B into 1 by square root of AB is equal to 6 by 10. Square root of AB and square get cancelled. We get here 2 times of square root of AB by A plus B is equal to 6 by 10. 2 ones are 2 threes. 2 threes are 6. If you do inverted now, we get here A plus B by square root of AB is equal to A plus B by square root of AB is equal to 3 by 10. Or here also square root of AB is equal to 3 and A plus B is equal to 10. Right here this one. A plus square root of AB by A plus B is equal to 3 by 10. 3 by 10. Square root of AB value 3 and A plus B is equal to 10. By trial and error method, clearly square root of AB is equals to 3. That means AB is equals to 9. So AB value A is equals to 9 and B is equals to 1. Or B is equals to 9 and A is equals to 1. A 9 into 1 is nothing but 9 only. Square root of 9 is equals to 3. 9 plus 1 is equals to how much? 10. So A and B value how much? 9 and 10. So A is to B is equals to A is to B is equals to 9 is to 1 or 1 is to 9. That is 4q plus the value of 4q plus 5q plus 6q plus and so on up to plus 10q value. So this value solution, if you do 4q, 5q, 6q and so on 10q, we get the answer is very difficult. So that's why this can be written as 1q plus, add 1q plus 2q plus 3q plus 4q, next up 4q plus 5q plus 6q plus and so on plus 10q, again minus 1q plus 2q plus 3q. 1 cube minus 1 cube get cancelled, 2 cube minus 2 cube get cancelled, 3 cube minus 3 cube get cancelled. This expression not at all change any values. So sum of the cubes of first n natural numbers is nothing but n square into n plus or n10 into n plus 1 by 2 whole square. Sum of the cubes of first n natural numbers. So that's why here n is equals to 10. Take 10 into 10 plus 1 by 2 whole square minus here nothing but n value 3. So 3 into 3 plus 1 by 2 whole square. So 2 ones are 2 5s. 11 55 whole square minus 3 into 4 by 2. 2 ones 2 2s whole square. 55 whole square. 55 into 55. 55 into 55. 5 5 is 25. 5 5 is 25 again. Goes 75. Again goes 75. 5 12 10 3025. 3025 minus 6 square is nothing but 36. So 3025 minus 36. 15 minus 6 is nothing but 9. 11 minus 3. 11 minus 3 8. This is 9. This is 2. That is answer is 2989. 2989 is the answer. Next, 10th one. If nth term of the given sequence, Tm is equals to n into n plus 3. Then what is the sum of their n terms? What is the sum of their n terms? We want sigma Tn. Sum of n terms is nothing but sigma Sn is equals to nothing but sigma Tn. Sum of n terms is nothing but T1 plus T2 plus T3 plus up to Tn. So that is equal to Sn is equal to sigma. This is n into n square plus 3n. If you multiply by sigma n square plus sigma 3n. We know that sigma n square value. Sigma n square is nothing but n into n plus 1 into 2n plus 1 by 6 plus. If you take 3 as common, 3 has come. We get sigma n. Sigma n is nothing but n into n plus 1. Right? Clearly, n into n plus 1. N into n plus 1 has come. N into n plus 1 by 2 has come. Reminder here, 2n plus 1. 2n plus 1 by 3. Observe here, n into n plus 1 into 2n plus 1. 2 3s are 6. If you take n into n plus 1 by 2 has come, we get here 3. n into n plus 1 by 2 has come, we get 3. So this is n into n plus 1 by 2 into, if you do LCM, 2n plus 1 plus 3 3s are 9 by 6 3. So we get here n into n plus 1 by 2 into 2n plus 1, 2n plus 10, but if you do multiplication, n into n plus 1 into 2n plus 10 by 2 3 is 6 is the n into n plus 1 into 2n plus 10 by 6. That means Tn is equal to n into n plus 3. Then we want sum of n terms. Sum of n terms is nothing but sigma Tn. Sigma Tn is nothing but n into n square, n into 3 you get Tn. If you multiply with sigma n square plus sigma 3 times of n. So sigma n square formula we know that n into n plus 1 into 2n plus 1 by 6. If you take here common sigma n value n into n plus 1 by 2. If you do LCM we get this one.